Here we will look at interpreting cumulative frequency graphs. Graph shows information about the time taken to solve a puzzle. Now let's just check this. Remember, this y-axis is our cumulative frequency. So 40 shows us 40 people. How many people took less than 30 seconds? Let's find 30 seconds on the x-axis. We go up and read across. Oh, it's a little bit higher than that. So it would be 34. How many people took less than 10 seconds? So again, don't forget you've got to remember this is a less than chart. So this is 10 seconds. So it'll be 6. How many people took longer than 25 seconds? Let's just go to 25 seconds here. Right, now, less than 25 seconds would be this part of your chart. So more than is this part of your chart here. So can you see it between those values? So it would be 10 people. How many people took longer than 35 seconds? So we'll read up to 35 and across. And we can see it is 3 people. The fastest 10 people completed the puzzle in under how many seconds? So my fastest 10 people are down here. They completed it in a really fast time. Let's say under 14 seconds. And the slowest 2 people, which are right at the end here, because they took quite a lot of time to complete it. So I read across from 48, be there, it'd be 36 seconds. Okay, maybe have a go at this one yourself. Put me on pause. See how you get on. How many cars travelled under 50 kilometres per hour? So on the x-axis, we've got the speed. 50 is here. It was here. Now let's just look at the scale. So we've got 30, 10 boxes. So 30 divided by 10 is 3. So each box represents 3. So 3, 6, 9, 12. 12 cars. How many cars travelled over 110 kilometres? So let's find 110, which takes us to here. Now, over is this part. So it would be each mini box was 3, right? So it'd be 3, 6. Okay, part C. 42 cars were exceeding the speed limit. So they were going fast. So we're going to be looking at this part. What is the speed limit? So 42 cars, each box is 3. We've got 30 there. We need another 12. 3, 6, 9, 12. So take us to here. Let's go across. So 90 kilometers per hour. And your example, do really like these types of questions for part D. Mr. Rogers says 18% of the cars were travelling too slow. So we need 18% of the cars, 18% of 150, which is 0.18 times 150. 27. Travelling too slowly on the road. Below what speed does he feel is too slow? So we need the slowest 27 cars, which would be up to here. So 60 kilometers per hour. Okay, you also need to be able to find the median and interquartile range from a cumulative frequency diagram. So the median. Okay, so how many people are there here? Don't look to the top, it's not 70, it's to the top of your drawn curve or straight lines joined together. So it's 60. So 60 people in total. We're looking at the ages of the 60 people by the looks of it. So what's the median age? What's the age of the middle person? So the 60 people, what's the middle person? Would be the 30th person. But the median isn't 30. We need to know the age of the 30th person. So let's read across and down, and we get 33. So the interquartile range, remember, is a measure of spread. And to find the interquartile range, we need the upper quartile minus the lower quartile. Okay, so if the median's at 30, where's quarter along the data? So half of 60 is 30. A quarter of 60 people is 15. So that's where you're going to find the age for the lower quartile person. And the upper quartile, what's 3/4 of 60? 45. Remember, you've got to read across and find their age. So the lower quartile is 25. Upper quartile, 40. So the interquartile range, 15. Okay, so for these two questions, have a go at finding the median and the interquartile range. So we've got 160 people here, and we're looking at something to do with time in seconds. So the middle person would be the 80th. So 32, 34 seconds. The interquartile range, we need the upper quartile minus the lower quartile. So the lower quartile, quarter of 160, which is 40. And the upper quartile is 3/4, which is at 120. So we've got 50 minus 28, which is 22. Okay, here, the next one, the median. Halfway through your data, we've got 40 people. Well, I assume it's people. No, it won't be people. People do not have a mass of up to 5 grand. Don't know what this represents, but the median would be 3.4. And then to find the interquartile range, the upper quartile minus the lower quartile. So a quarter of a way along is here. It'll be 2.6. And the upper quartile is at 30. .8, which gives you an interquartile range of 1.2. Okay, let's have a look at some exam questions now. Put me on pause and unpause when you're done. So we've got a cumulative frequency graph, gives information about the times it took people to complete a challenge. Find the median time. Got 80 people, middle person's at 40. How long did it take them though? So each box here is 2, so 68 seconds. Find the number of people who it took longer than 80 seconds. 80 seconds takes you to here. I've just read up from that line there. Longer is this part of your graph. So if we go across, it's here. So it'll be 10, 11, 12. 12 people. Right. We'll just have a question where we've got to fill in the cumulative frequency table. So I included this question because this is how your exam board set out these types of questions. So 0 to 1 is 8, 0 to 2. So it's almost like you're adding them up like this, if that makes sense. 18 here, 18, add 21, add 19, add 13, and then add your 9. And then we're going to draw on the cumulative frequency graph. Okay, so starts at 0, 1 to 8, 2 to 18. Don't forget we're plotting the upper bounds against here. 3 to 39, 4 to 58, 5 to 71, and 6 to 80. Now, once you've drawn this, we need an estimate for the interquartile range. So your interquartile range is upper quartile minus lower quartile. So 80 people, median's at 40, lower quartile is at 20. Let's just read across. Now I've just not joined that up very well. I'm going to join it up again. No, it wasn't too bad. Across and down gives me 2.1. And the upper quartile will be at 60. Which would be 4.2. 4.2 minus 2.1, 2.1. Cumulative frequency graph shows the information about the ages of 300 people who live in the village. Find the median age. 300 people. Median's 150. So 3246. Cumulative frequency diagram shows the distribution of speeds for 60 cars on the road. Estimate the interquartile range. 60 people. Median's at 13. Lower quartiles at 15. Upper quartiles at 45. But we need the speeds. So it would be 70, minus 46, which is 24. Speed limit on the road is 90 kilometers per hour. How many cars exceeded the speed limits, went faster than the speed limit? So it's just these ones here. So it'd be 2. Okay, last question. Cumulative frequency shows information about the length in meters in minutes, of each of 80 films. Claire says more than 35% of these films are over 120 minutes long. Is Claire correct? Give a reason for your answer. First of all, we need to work out 35% of 120, which is 42. So she's saying that 42 films, cars was the last question, are over 120 minutes. So let's look 120 minutes. And then more than is like this part here. So how many films do we have? 10, 20, 25. So is Claire correct? Well, Claire says 42 films are over 220 minutes long. So she is incorrect. 25 films are over 120 minutes long.